Okay, so shall we begin? So I was like having some trouble with my webcam earlier, so hopefully everything is gonna work perfectly as usual, right? So anyone else hanging out in there? Nobody's hiding in the background for attendance. Nate is not here, and Raiden, neither of those folks are here. Is that right? Okay, I'm gonna take that as a that's right. Okay, so let's see. We are talking about objects and classes today. Is the music okay? Is it too loud? Should I turn it down a little bit? Okay. So let me know if it gets up to be too high. It's a bit low. Well, I guess the song is really low, so okay. So today we are talking about objects and classes, which are super important for code in games, especially like looking forward into like if you end up taking GD205 code for games, or anything you're doing like with Unity or Unreal or anything, objects and classes are going to be really important. And so this is for the most part like the last like major coding concept we talk about in this class, and so it's a bridge topic that will bring you into the stuff you're doing in the future. So Unity is not evil, it's just complicated, right? So if you end up taking GD205, which is code for games, Unity will be a lot less scary than it is right now. Like for instance, if you're taking GD201, then it might seem like overwhelming for you. So, okay, so we're talking about classes and objects. So can someone give me an example of a class like in the world? Like what is an example of any class of anything in the world? Not necessarily like computer science class, but like, so Brianna said isn't like a category, so yeah, and you could think about HTML too. So Linda said school. So like for instance, this is a class right now, right? So this is GD105. So there are an entire category of thing called classes, right? So we have, you know, you may be taking some other classes, like for instance, you might be taking, like we were talking about languages earlier, so you might be taking like Spanish class, for instance. It might have a designation like SPA 101 or something, classified, and it's in the same section. I'm not sure what you mean by that. But we have, all classes have something in common. So like for instance, all classes have well, it makes it a little bit hard because this semester is weird, but like normally you could say that all classes have a time slot, right? They have a day of the week or 2 days of the week or 3 days of the week that they happen on, and then they have a time that they start at and a time that they end at. And so they can be said to all have that in common. That's something that all classes, like school classes, have in common. What else do school classes have in common? Like what's a feature that they all have? Besides like time slots and names. So this one is code for art and design. So they have instructors, right? Professors. So every class has an instructor or instructors. Students, yes. So all classes have students. If they don't have students, it's not a class. It's just, I don't know what it is. It's canceled if there are no students. And so they might have a number of students, for instance. They might have like 10 students, or they might have 100 students. So OSOS, you don't have too many classes like that, thankfully. When I was an undergrad, I took an intro to theater course. I hate theater, by the way. I mean, nothing against theater, but it's just not my thing. So they consist of lessons, right? And so, anyways, I was taking this theater class, and it was like an auditorium with like 500 or 600 people. Yeah, I just took it because it was an easy grade. In Texas, we call these blow-off classes that you take just because they're easy because you need the credit. Has anyone taken any blow-off classes, or easy A, or I don't know what you call them? What do you call them? Surely there's a name. Has anyone taken a class like that? You just took it because you thought it was going to be easy? I don't recommend this, by the way. I actually recommend taking classes you're interested in. So it helps if you have like a major that you actually care about. So Barshar, what have you taken that is like that? Class was it? Brianna, drawing and painting was a blow-off class. Because it was easy? Painting? So yeah, I took painting and it was hard actually. The painting class I took, I got like a B-, and I thought it was not bad. So of course it depends on, you know, the instructor and how hard they are, and you know, the goals for the class. But yeah, I don't remember anything from theater. Yeah, so like, you know, here we have, oh, by the way, if anyone's interested, if you have not taken painting and drawing, next semester they are offering, there's a new course that is called Foundation Drawing, which is just a drawing course. So if you're interested in that, that can count as an elective if you still need an elective. So, ooh, I got an auto mod notification. So careful with the language. So yeah, so consider that if you look in the schedule, it's GD100 if you're looking for that class for the spring. It's a new class, so it just got approved this past spring, and you can't run it for like a year, so it's running next spring. If you're interested in taking that in addition to VPA 121, hi Nate. Just talk to me during my office hours or something. We can probably work it out, but I'll just need to look at your schedule. So anyways, there are other classes of things. So I'm like looking around. Yeah, we had to draw 2-figure drawing in my drawing class. So not in my painting class. We just did still lifes. They were pretty boring for the most part. But in my drawing class, we did live nude models. And that was hard. We would do where we rotate all the way around the room, so we have to do quick sketches of the person from all these different angles. And disgusting. There's nothing wrong with people's bodies. So let's see, I'm just trying to find whatever I have within reach. So we have like some things like what do I have? I have multiple cards, it looks like. So let's say, so I don't know if they had a ban or what. So usually when it's men, it's usually old men who don't have anything else to do. Excuse me. Just something that's stuck in my throat. Okay, so other classes of things. We have, let's see, I can't even tell where. This is a card. So here's another card. Oh, like this is from my insurance agent. Thank you, insurance agent. And so like cards could be described as a class of thing, right? So they all have certain things in common. So they all have, what kind of features do cards have? Like this. What kind of properties do they have that they have in common as a group or a classification of things? Classification. So like they all have like covers, for instance. So each one of these has a different cover. So yeah, visual design. So they might all have like an interior, and they probably have writing inside. So even though they all have writing, they might have different writing. This one has some writing, one has some writing. And so there are things that classes all have in common that get them grouped together. But they still have some things that differ. So what about what about this? What would you say this is a class of? What is the category or the type of thing that you see on the screen in the slide? So it is an alphabet. That's one way to describe it, but let's say it was just a bunch of letters, right? The names could be different. The names in the card, you mean? So we could say that these are letters, right? Or characters. Like for instance, all letters have something in common. Like they all have ways that they're written, for instance, like they all have different shapes. So we can see like, oh yeah, I can try this feature that I've never used. Ooh, the pointer. Fancy, right? So like for instance, the O is like a circle shape. The P is like a line with like a half circle. Q is like a circle with like a squiggly line in the bottom right hand corner. What else do letters have in common besides that they are all different shapes, represented by different shapes? So come on, you know. Like what is the first thing you associate with letters? So words, so they could be like, they go together to make words, right? And pronunciation, that's the one I was thinking about myself. So they're all parts of language. So each one has a sound that represents it, and that sound's going to be different for different letters, usually. English is a little tricky. But they have those things in common. So all of these things are part of the class called letters. So the type of thing, the category of thing. And so when we talk about object, we're talking about a specific instance of a class. So a specific instance of a letter might be A, or O, or N, or X. So an object is a specific one. The class is the general, broad category thing. So like these may be like from the class cards, but an individual one is an object. So an object is a very specific one. Does that make sense? I hope that makes sense. And so when we talk about classes, they have properties that they have in common, and they have functions that they also have in common, things that they do. And so when we're using objects and classes with code, we use it because it helps us with management. It makes things modular. It makes everything well organized, so we can structure things in a way that makes sense. There's a certain kind of hierarchy that we have that makes everything easy to read. So when we use like custom functions, that was like the first step toward looking at classes and objects. So there are some classes and objects that are already familiar to you. So like for instance, last week or the week before, we used pimage. I think that was 2 weeks ago. Pimage is actually a class built into processing. So typically when we use a class, it has a capital letter. And when we're talking about objects, they have lowercase letters. So pimage is one of the classes that's built into processing. So we're going to be making custom classes ourselves. And so let's say that we've been doing lots of things with like sort of like circles, or like a ball that will move around the screen, for instance. And so like we might think about like some of the data points of a class of ball. And so by data, I'm just talking about like properties basically. So like what kinds of things do all ball objects have in common? You might say that they all have colors. They might not be the same color, but it's a quality that they have, right? They might all have a size. They might, if they're moving, they might all have a speed on the x-axis and a speed on the y-axis. They might all have an x and a y position if they're going to be drawn on the screen. And then methods. Method is just a fancy word for function that's within a class. So remember, a function is just something that something does. And so if we're talking about a ball object, we might say that it has collisions. Maybe it moves around the screen, for instance. And so when we are looking at the way we've been doing things up to now, we might be doing it like this, where we have a declaration at the very, very top of our sketch where we declare all of these variables individually. We might assign them inside of setup, where we give, maybe we give the size a value of 20, maybe we give the x position a value of 50, etc. And then inside of draw, we have where we're actually drawing them. And so the difference when we're looking at object-oriented programming, I feel like this is a little bit, is this too loud? It's a little too loud for me. When we're looking at object-oriented programming, we're actually talking about first declaring an object, and then we're initializing the object inside of setup, and then we're displaying the object inside of draw. And so this is very helpful because this allows us to do things in a very simple way that we're going to do it very over and over again. So like, for instance, when you have a class of something, you can think about it as like a factory. You have a factory where you can produce these things. They might all be different, but once you have the factory, it's much easier to produce, like for instance, like this can, than it is if you were to make an individual one. So if you were to make an individual can, like with your own aluminum and your own like paint and energy drink, would that be easy? I mean, it probably wouldn't be easy, right? This is Ultra Sunrise. I've actually talked about this before, last week or the week before. Very good flavor. It just tastes like orange soda, so I like it. Yeah, so like if you were to make an individual one, it's a lot of work. But if you have a factory where you can produce these, the hardest part is building the factory. I'm not joking, it's really good. Now I'm thinking about Monster. I guess we're all thinking about Monster. So like the factory. So if we have a factory to make these, it's a lot easier to make an individual one than it is to make an individual one without the factory, right? So if you drink energy drinks, just limit it to one a day. I think the only time people have issues is when they like get addicted. Like I have a friend, she drinks like 5 energy drinks a day and she like never sleeps. And I worry about her. So yeah, moderation. I don't drink coffee, so. Okay. So when we're making a class, so like let's say we want to make a custom class, it's gonna have we all gotta die someday, right? The class has a name that describes the class. There are data fields, which are basically just variables that are associated with the class. So for instance, like a can might have like a color associated with it. It might have text written on it. It might have a flavor inside. And then we have a constructor, which is basically like a setup specifically for this class. So normally in the past, we've been just stuffing everything into setup. When we use a constructor, it's like a way of segregating it out. So it's all just within, all the things that are setting up the object are inside the class. And then we have methods, which are just functions associated with the class. And you're like, I don't know what you're talking about. And that's okay. So if we're looking at the sample structure for a class, it will look like this. So it's very similar actually to our sketch overall. So we have a sort of is good, sort of is good. We're going to get to more than sort of. So we have, first of all, the class. So we're declaring a class, and so we use class because that's our type, the type of thing that we're declaring. So similar to how you have a variable and you use the type and then you give the name. And so in this case, you might notice that the name of this class is name, but it's a capital N. So the convention in code is when we are talking about class names, we use capital letters for the first letter of the class name so that we know we're talking about the class and not an object. So that's something that is very important later. It's like not essential knowledge, but it will help you a lot, especially if you start working in Unity. So like, because for instance, when we make variables, we usually just start them with a lowercase letter. And so that we could give them a capital letter, but then we might think that they are class names. So this convention is here. So like when you see code, when you see that capital letter, you'll know to associate it with a class name rather than an object or a specific one. So in here, we have two variable declarations. So in the top of within our class, we have the curly brackets to start the class, right? And then we declare two floats. So this is just an example. So similar to how we have our sketch, we have our declarations at the top. And so inside of our class, we have the same thing. So it's like sort of a structure within a structure. So we have our variable names, and then we have our constructor. So the constructor is basically like, it's just the name of the class, open and close parentheses, I don't know what you mean, and then curly brackets. And so the constructor, again, is just basically the setup for the class. So in the same way that you give those initial assignments inside of setup, you give the initial assignments for the variables associated with class inside of the constructor. Lots of new words. So it goes in here. So constructor is just set up for the class. Then we have methods. So these methods, again, are just like functions. So when we did custom functions before, remember we made one for for dice, right? To make dice and dice rolls. So here we have methods are just functions associated with this class. So maybe with this class, we might want to have it have a move function or method. So we put the code in that we want to associate with that thing happening. So in this case, it's moving the pose X by 5, so making it 5 more than it was before. We might also have a display method where we do the actual thing, the code that displays the ellipse in this case. And so you might think about a class as the general thing, the object as a specific thing. So when we're setting up the class, we're basically making the factory that's going to produce all of the individual ones. So you can think about it as like we have a cookie cutter that is cutting out individual cookies. The cookies are going to be different ultimately, but it helps us to make those cookies. And so we might think about a DualShock controller, and I don't even know what the PS5 controller looks like. Oh no, I do, because people have been sharing it on River. I'm probably not gonna buy a PS5. Yeah, oh yeah, it looks like, yeah, it looks like the PS5. It's subjective, right? Whether it's beautiful or not. So when we talk about the class of DualShock controller, we're talking about like, we're not talking about like this DualShock controller, not this specific one that's red. No, not this one. We are talking about, nobody wants to be famous here. We're talking about like the idea, the general DualShock controller. So like if you think about like the blueprint in the factory, that's the class. And so everything has like all things that are DualShock controllers have the general things in common. So I think the bot got scared away. So this is the general. Oh, sorry. Now I'm confused. God damn it. Go away, bot. You're like tripping me up. Yeah, go do bot stuff in your bot world or whatever. Whatever bots do in their downtime. Go take a vacation. So, yeah. Gosh. Snowflake bot. Kidding. So again, this, and you can, I don't know if you can tell, this is like a computer rendering actually, so it's not even a real one. So this is like the idea of the DualShock controller, right? And there are multiple DualShocks, right? There's like the DualShock 2, 3, 4, I don't know. I don't know if the new one's called a DualShock or not. And so we have methods for the DualShock controller class. So for instance, you might have like a button press. So all DualShock controllers have buttons that could be pressed, right? And that button will do something when you press it. So there are specific things associated with each of those buttons. So they also have like other kinds of input, like there's like a microphone I've never used ever. It's a speaker. It's a speaker, but there's a microphone jack. I only use this for my computer for the most part in single player games on my PS4. Except the start button at times. What start button? There's no start button. And so we also have data fields or properties or variables associated with this. So we might have, for instance, this is just an approximation. We might have a Boolean variable for like the X button. So for instance, we could think about the X button as having two potential values, right? We could think about it as having like an on or an off value, a true or a false value. We might think about a left analog stick has like an X axis, so that could be like one value or another. It might also have a Y axis, so we could think about that as another type of thing. It's actually like a float if you start working with controllers. So all of these things are, all DualShock controllers will have them in common, right? They all have left analog sticks that have an X axis and a Y axis. They all have X buttons that can be on or off. So I stopped playing Call of Duty. I don't play that anymore because I don't like Battle.net. So when we're looking at an object of the DualShock controller, we're talking about a specific one. So this one is like made of gold, right? So this is not like the general class. This is like someone's specific DualShock controller. Like this is my DualShock controller. It has my like hand dirt on it. It has my germs on it. It has like, you know, some like scratches and stuff. And so like DualShock controllers don't all have those things in common. They don't all have the same scratch right here. And so that's something that's specific to this one. And so these are other objects, examples of DualShock controllers. So for instance, we have this one covered in, I don't know what that is. Grease. It looks like enchilada grease or something. And this one is like broken. And so these are specific ones, right? So these are objects. These are not the class. They are of the class DualShock controller, but they are specific instances. So that's the object. I would not do that. There's like this Twitter account. I don't know if you've seen it. It's called like Gripping Things with Rage. It's like people like grabbing foods and then squeezing them until they like explode all over their hands. It is the worst thing in the world. It's very upsetting because it's like people wasting food. So I do not recommend looking at that unless you like looking at terrible things. I am not a rage gamer. Okay, so now let's get into some actual code. So let's go ahead and make our own. So let me find where I have hidden processing over here. And so I am just moving this stuff around. Okay. Okay, so let's see. Is this a good spot? Okay. So we're going to go ahead and make our own class. So we'll just get our sketch started. And so I'm going to create my setup and my draw. So I will give it a size feel like we're going very fast today for some reason. Maybe it's because like people are very like active, which is great. I'm very happy for you all to be very active. Thank you. So maybe I'll make this like 1280 wide by like 720 tall because I'm very creative. And so when we want to declare, so like one of the most common classes that you'll see in games, so like a lot of games have the concept of an enemy, right? So if we think about like how we can represent this, we can use classes because, you know, we might have an enemy. All enemies have stuff in common. So for instance, like within a game, you might have like 50 different enemies, but they all have like health, for instance. Each one might have a different health level, but they all have health in common. So like that's something they all have. They might also have a number of like hit points or a number of damage that they do, for instance. So we can start to represent that using code. So we're going to go ahead and make a class. Sonic and Eggman is a prime example. Eggman's an example of an enemy. I don't know about Sonic, maybe like Metal Sonic or Metal Sonic as an enemy. So when we want to declare the class, we use class first of all, and then we use the name of the class. And again, we start it with a capital letter. So I'm going to call this class enemy. And then we use our curly brackets, right? So we have now declared a new class called enemy, and we're going to put it inside of these curly brackets. So we need to now think about like what are the actual properties that we associate with an enemy. So let's say that it's going to be represented with like a circle on the screen. So we might think about it as having like, what are some properties that we've had with like when we were creating like a ball moving around the screen? Like what types of variables did we create to store stuff about them? Does anyone remember any? So how about like we had floats for like X position, for instance, and Y position. So, you know, whenever we draw something on screen, it's going to need an X position and a Y position. You know, we could also call this just like X and Y. It's just arbitrary. So they might have a sprite. I'm not going to get into that right now, but I will show you an example later. But that is something that they will often have. They'll often have like a whole bunch of sprites. And I have a great example later. If they are moving, they might have a speed. So maybe they have floats to store like an X speed and a Y speed. So if they're moving on the X axis and the Y axis, they might also have if they are circles, they might have a diameter. So maybe they have a variable called dia, for instance. So instead of like doing this at the top, we're putting it inside of the class. So this will help us stay organized, and we know that all the stuff that we put inside the class has to do with this class and nothing else. So also when we see this code, we'll understand it better because we know this X and this Y has to do with enemies. So all enemies will have an X and a Y. So it might also have some kind of health variable, right? So it might have a float to store that health amount. Let's say that maybe it has like it's alive or it's not. So like if what would be a good variable type to create a value for whether it's alive or not? If it can only have two possible values, that it is alive or it is not alive, what would be a good variable type for that? Does anyone know? Oh gosh, var, you're getting into like, oof. So var is not something we use in this class. But I mean, that's true that you could use something like var. But let's say that what's something that we've used in this class? That would be good. I think you're thinking a lot about like JavaScript and web design maybe. So let's say that it has like, so like we actually wouldn't need 2 variables, we would only need 1, because like alive and dead can be encapsulated with something that is true or false if it's alive. If alive is true, it's alive. If alive is false, it's dead. So we wouldn't need alive and dead, we could have alive or dead. So what would people prefer? Do people prefer to use a variable called alive or a variable called dead? If dead. See, that's a good one, then we're going to use that. Okay, so let's use dead. So we would use a Boolean, so don't forget that Booleans have 2 possible values, true or false. So they're very well suited for this. So we'll call this one, I'm going to spell it correctly. I want to spell it like this, but I want to make sure it's clear for people later. So we'll make one called dead, so it can be true or false. And so now we need to make the constructor. So don't forget that the constructor is basically like the setup for the class. So all of the initial values that we associate with all of these variables get assigned inside of the constructor. So to write the constructor, we use the name of the class, which is enemy. And then we use the open and close parentheses, and then curly brackets. So this is going inside of our class. And so inside of here, we will give the initial starting values for all of our variables that we've created. So for instance, let's say we want the X to start off. Let's give it a random value between, let's say 100. So that's like the minimum value would be 100. And let's say the maximum value would be width minus 100. So that's like basically put it somewhere on the screen, but not on the edges. So instead of starting at 0, which would be the left side, start it a little bit inside. And instead of width, which is the right side, a little bit before you get to the width. So it will randomly spawn somewhere on the x-axis that's not quite at the edges. And so for the y, let's say we wanted to put it in the middle of the y-axis. So like what could we use for the middle of the y-axis? What would be like halfway down? Any ideas for how to do that? Height divided by 2. So that's the height is the bottom, right? So height divided by 2 is the middle. And so we need to give these variables initial values in the constructor. So we might have x speed equals random. So let's say we want it to be a random value between -5 and +5. So again, when we use random, if we use 2 parameters, like, you know, 2 things separated by the comma, we're saying the low end of that random value and the high end. So we're saying between -5 and 5. So remember, if it's like a negative x speed, that's like moving left. And then +5 would be to the right. So we can do the same thing for the y speed. So we can give it a random value between -5 and 5. And so for the diameter, so what should the diameter be? Someone give me a value. How big should it be? What do you think? 300, okay, got a big one, all right, no problem. And so now we have to do health. So what should we start the health at? What would make sense to you all? There is, okay, so like 100, sure, that makes sense. I mean, there is music, right? So, and then for dead, our last one, what should dead start off at? So if we have an enemy and we create it, should dead be true or false to begin with? So yeah, so this is for the enemy, so we got 100. And so dead should be false, right? Because we want the enemy has to die before it's dead. So it starts off alive. So now we have our constructor. And so we need to think about what kinds of methods do we want now? So what kinds of things are the enemy going to do? So one thing that's very important is displaying the enemy. So we might have where we want the enemy to be displayed so that people can see it on the screen. Sorry, it's like, it gets confusing when there's like, if I ask a question and then people start saying stuff and then it kind of gets confusing what the question was. So let's see, we want to display it. So we can create a method called display. And so remember, a method is just a function within a class. So this will only be associated with this class. And so we have where maybe we have where we're drawing it, right? So we use ellipse because it's going to be a circle, just represented by a circle for right now. And then we use our X, our Y, and then our dia for the width and height. So this will draw it at the X for the X position, Y for the Y position, with a width of dia and a height of dia, so it's a circle. Maybe we also want to draw it with like no stroke, because I don't like outlines. I'm biased against outlines. So by using no stroke, it will not have an outline. So let's think about the other things we might want to do with this. So if we were to have something that, let's say the enemy was like moving around the screen, right? We might have it bounce off the walls. So yeah, this is just for the enemy class, but like with this, we can make 100 enemies that all follow the same rules. So it's very powerful. So it's like we're setting up the factory so that we know how to produce them and that they all operate the same way. So we might have a method in which we check for those collisions, check to see if it's bouncing off the walls. So I could call this check collision. And before I make this one, it's also important for the enemy to move, right? Moving is a very important part of what enemies do. So I might make a method. So yeah, so like basically we're setting up all the stuff here and then we can make as many as we want. And it'll all follow the same rules. So it's very, very powerful. So I'm going to create another one called move. And so if we want it to move, we might want to check first to make sure it is alive. So how would we make sure that it's not dead before making it move? What kind of thing can we use to check if it's alive or dead? Actually gave it away. So we made a variable called dead, right? So if we want to check that, so I mean, println could give us a message in the console if we wanted to see that status. But like if we want to be able to check it in the code to see if it's true or false, we could use an if statement. So we could use if. And so if we want to check if it's alive, it's like saying if it's not dead, right? So does anyone remember what character we associate with not when we want to indicate not with code? To be able to check if it's not dead. Anyone remember? What did I say to associate with not when you see not? Or when you see it, think not. Anyone remember? It's a character. It's somewhere, it's like if you hold down shift and press one of the numbers at the top, it's one of those. I mean, we could do that. We could say if dead else. What about this one? Do you remember this one? Exclamation point for not. Does that ring a bell? I hope it rings a bell. Exactly. So if not dead, then do a thing. So this will check if it's not dead. So the exclamation point means not. So if it's not dead, then make it move. Because if it's dead, it should not move. Dead things hopefully don't move. I mean, I guess in a lot of games they do move because they're like zombies or demons or something, but in this game, dead things stay still. So if it's not dead, we want to make X move. So we will say plus equals X speed. And then for the Y, we might say Y plus equals Y speed. So this will modify the X position by X speed, and then it will modify the Y position by Y speed. And so before I complete this additional method, let's just first try to create an object now to see if it works. So our class is in a state where we could try to run something. And so we need to actually now create a specific object. So we need the factory to pump out can, or an enemy in this case. So when we want to declare something of that class, so like at the very top of our sketch, back to the very top, we're gonna go ahead and declare a new enemy. So the type is first, right? So the same way you declare a variable or anything really in code is that use the type. So the type is enemy. So we're gonna create a new enemy, and this enemy will be called my enemy, my own personal enemy. So we're declaring a new one and we're calling it my enemy. So an important part of creating a new object is that we need to initialize that object. And so inside of setup, I'm going to write my enemy equals new enemy open close parentheses semicolon. So what this will do is it will actually create a new object and it will run the constructor. So it will basically find the enemy class and it will run this. So when it runs this, it will give the X value, the Y value, the X speed, the Y speed, the diameter, etc. So it's assigning all of those initial values. And so that's what we need to do in order to initialize our object. And then inside of draw, we can go ahead and run all of the methods associated with our with the enemy class. So I'm going to use the name of our object, which the name of our object is my enemy. Dot. So I can use what's called dot notation to access things within something else. So I can now access the method name that I want to run. So if I want to run the move method, I write move, open and close parentheses. So this will look and it will run the move method for my enemy. So it will find this and it will run this code inside of here, specifically for this one object. And if I want to display it, I can use my enemy.display, open and close parentheses, semicolon. So this will do the same thing before display. So let's run this. And so you can see we're not clearing the background, so it just kind of moved off screen. So what if we cleared the background first? So I'm adding background in my draw. And so if I run this, you can see that it's giving that random speed, right? So sometimes it goes slow and sometimes it goes fast, and it's always at a random position on the x-axis. And so we were saying if we wanted to make it bounce off the edges, we would need to create that method called check collision. And so we need to actually fill it out so that we can get that functionality in there. So the enemies, so all enemies that we create will be able to have that functionality. So we might want to check if the X position, so if X goes beyond the right side of the screen. The name of this song is Rio Road Trippin' by Ozoyo. Rio Road Trippin' by Ozoyo. I just put it in the chat. So we might want to check if the X position goes beyond the width of the window. So like if the X goes to the right of the right side of our window, would be checking one side. And then we might also want to check the other side. So if we want to check the right side, what would be the other side that we want to check associated with the x-axis? What's the other side? So we might check if x is less than what for what side. So we could use that, but so if we think about it, there's the right side and the left side on the x-axis. So if I wanted to check if either it goes beyond the right side or beyond the left side, so we don't want to check if it's less than width, because it should always be less than width because it should be on the window somewhere. So if we want to link two potential conditions, so if either one of these are true, we can use OR. So remember, OR is represented by the double pipes, the two lines. And so the second condition, if x is less than 0. So this is checking if the x goes beyond the right side of the window, if it goes beyond width, or if x goes to the left less than 0. So if it goes beyond the left side of the window. So if either of those are true, then we want to reverse the x speed. So x speed times equals -1. So this will take that x speed. So if it's like positive, meaning it's going to the right and it goes beyond the right side of the screen, reverse that direction so it goes left, and vice versa as well. So we'll want to do the same thing for the y. So we want to check if y is greater than height, so that's the bottom, or if y is less than 0. And so in this case, if it goes beyond on either way, we want to do the equivalent for the y. So we want to reverse the y speed. Y speed times equals -1. So this will reverse the x if it goes beyond the right or left side, and this will reverse the y if it goes beyond the bottom or the top. And so let's see if that works, but first we have to make sure that we call this method. So going back up here, so where we call move and where we call display, let's go ahead and call our myEnemy.checkCollision to be able to check if it actually is working. So now you can see that it is bouncing off the sides. So our enemy is doing all the things that we said it should do. Which is great, right? So let's say that we wanted to have some kind of way that it can die, I guess. Enemies die all the time, right? So inside of our check collision, we can also add some functionality to be able to check if the cursor is hovering over it. Maybe that's a way that it could take damage. So I could check if the distance, so I could use the dist function between the x position of the enemy, the y position of the enemy, and the mouse x and the mouse y. So if the distance between these 2 points are less than the diameter divided by 2, because it's a circle, so if it's closer than the radius, remember when I draw the circle and then the dot and see the cursor, if that distance is less than the radius, then we want to do something. Implode, like how Pac-Man implodes. I mean, we could do that if you want to do that. So let's say that this represents damage. So what do we want to do? What do we want to modify? Like among our variables, if we wanted to start taking damage, what should we modify? to start taking damage? Which variable should we start changing for the enemy to take damage? Which one? So probably not the X or the Y or the speed. I mean, we could, but what would be most important? Would it be the diameter or the health? Or should it just die if it like starts taking damage? Which one? Oh, the health, yes. Sorry, I missed that. So we can modify the health. So like if we want the health to go down, we can write health minus minus. So minus minus will be like take whatever the value it is and decrease it by 1. So if it's 100, make it 99. If it's 99, make it 98. If it's 98, make it 97. So then we might also want to check if the health goes below a certain amount. So if the health goes below what amount for it to die? What would you associate with a value of death? If 100 is full health, what would be no health? So 0, right? So we could say less than or equal to 0, because if it has 0, then it should be dead, right? And so if that's the case, then we want to make dead equal to true. So in this case, if the cursor is hovering over the enemy, the health will decrease. If the health goes below or is equal to 0, then dead will become true. And it will stop moving because this will no longer be true. So let's see if that works. So if I hover over it for long enough, it dies. Rest in peace. So maybe we want to like some kind of indicator for the player that this is happening. We might also change the diameter, for instance. So if we're changing the health, maybe we should make it smaller too. So we could do dia minus minus. I know it was harmless, right? It's so round, it's kind of cute. That big circle. So like now, if I hover over it, you can see that it's getting smaller. So that can like represent that it's getting hurt, for instance. It might also, like, if we want to try to show it more clearly, maybe when it's taking damage, maybe it should change the fill value. Maybe it should be like a random value between 200 and 255. So remember that 255 is white, so this is like, you'll see a little bit of flickering. So let's see. So now when I hover over it, you can see it flashes, right? Until it's dead. And so we have here just like a basic enemy class, right? So let's say that we want to actually make this enemy. And by the way, if you have any questions, throw them in the chat. So we've done one enemy, right? So let's say we want 100 enemies, which is a lot of enemies. Maybe we say, let's say 10 enemies. So instead of like making a can individually, making like 10 of these like handcrafted, we have our factory now, right? So we can make them very easily. So, or 11. So I'm gonna go ahead and create an array of them. So when we want to, I'll just make a variable just to keep track of how many I create. So I can make an integer called how many. But you got something against odd numbers. So I'm going to give it an initial value of 10. So let's say that we want to declare a new array. So we first use the type. So the type is enemy. And then we use the open and close square brackets to indicate that we're declaring an array. And then we'll call this array of enemies, we'll call it my enemies. And then we need to say equals new enemy, the type again, and then square brackets inside of the second square brackets at the end, we put the number of positions within the array. So we can use how many. So we're going to declare an array of enemies called my enemies, and we're going to carve out how many positions. So I'll do 11 since that was the suggestion. So then inside of setup, we need to actually initialize each one of the positions within our array. So all 11 of them. So we can use a for loop. So for, and we're just doing it the same kind of structure that we've done before. Int I equals 0, I is less than how many, I plus plus. And now we want to make sure that we do the equivalent of initializing for every single position within the array. So do you have to add the new part for your code? I'm not sure what you mean by new part. What do you mean by new part? So I'm writing out the name of the array, and then I'm using the square brackets. So the loop is going to help us because I is going to cycle through each one. So we put I in the square brackets equals new enemy, open and close parentheses. So when I is 0 the first time this loop runs, it will initialize the index 0, the first position, and then I will become 1. So it'll initialize the second position, which is 1, and then 2, 3, 4, 5, etc. Where it says my enemies equals new enemy. Do you have to add the new part? Yes, you do. So you have to add new when you're like reserving how many spaces in an array, and you also have to do it when you're initializing an object. So in either of those cases, you're going to write new there. So it allows it to understand that it's carving out space for that in memory. Or that's the way I think of it anyways. So now let's say that in our draw, we want to actually run all of our enemies of my enemies, our array of enemies. So we're going to do the same kind of for loop. I only stream classes. I am not a streamer, except for classes. Int I equals 0, I is less than how many, I plus plus. So we create a loop so that we can do it easily for each one within the array. My enemies, question mark? What do you mean by question mark? I equals, or sorry, my enemies dot, so we're doing the same things as we did up here, but for our array. So my enemies I, so the specific one within the array at that moment, dot move, my enemies I dot display, my enemies I dot check collision. So now we should have, oops. So now when we run this, we have 11 of them. And so one thing that's changing is that all of the colors are changing because we don't have a default color for them. You have to join us game streamers. Maybe one day, I don't know. Probably not. But you can see how easily, like, there are a whole bunch of them now, right? Maybe one day. Probably not. Just not my thing. So very easily we've been able to create this class, and instead of just having one, we could do so many. We could do, you know, 110 if we wanted to. That's too many. So you can see how we have so many in here, and so we can create as many enemies as we want. They all have their own independent lives. They have their own independent health. All of those things are independent. And so this is very powerful. So it's a lot going on there, but I'm just showing you how easily you can create them now, because now you have the factory, right? You could just pump them out. And so I was just going to show you all an example that I made. So I used to do like stuff like this in class, but I've been trying to stay away from photos to make sure that I emphasize that people should be making their own art when they make their games. So, but for this example, I'll just show you because it's great. So I made this game. It's sort of like based on this. So this was an example in class. And so we have all of these lovely Kanye enemies. And so if I hover and click on one, you can see that the default sprite, which is like happy Kanye, turns into like grumpy Kanye. And you can see like the background flashes. And also when Kanye is taking damage, you can see that Kanye has this like shocked look. And then when Kanye health gets to 0, Kanye stops moving and becomes a skull, right? So yeah, classes are great. Classes are very important. And yeah, I hope that made sense what we did today. I actually really like Kanye's music, but I hate Kanye West as a human being. And I'm very glad Kanye is not our president. That would be worse than anyone I can think of. I mean, it's kind of close with Trump, but you know, Kanye would be a bad president. I can say that, right? We can all agree on that. Nobody voted for Kanye, right? Please don't tell me you voted for Kanye. So we should not have narcissists in positions of power, no matter how good their music is. Okay? So I will post the code for these examples on River. So for next week, you're going to want to create a prototype, so that you're going to create the first prototype for your final project. So you already presented that concept, and so you're creating something that you're testing. You're trying to represent those core mechanics, so the key functionality of your game. So I also used to make one that was Kim Kardashian as well, but I feel like the Kanye one's funnier, because Kanye's just really easy to hate on. So yeah, I'm gonna post that later today. I hope you enjoyed the lesson, and I will see you on Monday. So Monday we'll be on Blackboard Collaborate Ultra as usual. Yeah, so thanks for tuning in. I will see you later. So the homework was for the you're making the prototype. Great. I am glad.